Okay, we're going to continue with circles. And one of the things I want to start off with um, is actually angle measure. And you'll see how it relates to circles. It may seem kind of odd that we'll be talking about angle measure when we're talking about circles, where, an angle, of course, it's not straight. I mean, it's just the sides are straight in an angle, right? Circle, arc, or curved. So, but the reason I want to talk about angles is because angles and circles are very closely related. If you've ever wondered why there are 360 degrees in a circle, it comes from ancient times. The Egyptians used 360 degrees in a circle. And where that came from is actually their calendar. So if you think about it, okay, there's the sun, right? There's the Earth rotating around, or not rotating, but orbiting around the sun. And it's not an exact circle, but it's very close. It's an ellipse, but it's almost circular. So here's the Earth rotating around, or orbiting around the sun, and it takes approximately 360 days to get around. 365, a little bit more. The Egyptian calendar had that down to 360 days. So they were very close. So if you divide this trip going all the way around the sun into 360 degrees, you get 1 day for each part of it, for each degree. Well, that's where you get the 360 degrees from. So now if you imagine yourself in the center watching the Earth, let's say we go from point B, so this is circle A. Now the sun is at, maybe I should have called this S for sun. Okay. Now as it goes from B to another part of the circle, I guess it would make sense to call that C, A, B, C. So there's a rotation. As you can see, look what's happening to, as we turn, there's a rotation. So you can imagine that right here. Now remember, this circle has been divided up into 360 days. We're going to call them, instead of days, we're going to call it degrees. So 1, 2, 3, 4, this took 32 days, let's say. Okay, I'm not sure, that's just a guess. Maybe I can find out a little bit more accurately. I'm going to use my protractor. Okay, it took a lot more than that, because we go 0, 10, 20, 30, 40, 50, 60. It looks like 70 days. So this is 70 days, but we're not going to call it days. We're going to call it degrees. 70 degrees went from here to here. Well, that's going to be our arc measure. Okay, inside the angle, like we started looking at point B, we ended up looking at point C. There's the angle measure. So that's how degrees of an angle and degrees in an arc are measured. Now, when we talk about arc measure, we're not talking about distance. We're talking about the rotation. Now, arc length, how far, like if you were walking along a path, a circular path, that would be different than the actual arc measure. The arc measure and the arc length, like I said, are two different things. So let's say we have another circle that has the same exact center. Okay. Now, let's say we have a planet here and a planet here, and they're going the same path, right? Okay. Even though this one might take longer to get, a shorter period of time to get around the sun, okay, this one right here is still going one rotation. So we're looking at rotations. we can still use the same degrees for that one. So if that's point E, and that's point F, this would be 70 degrees also. Now the length, like I said, the length and the measure are two different things, and you need to make sure you understand that. So the arc measure here is 70 degrees. The arc measure is 70 degrees. The measure will always be the same as the angle measure of the central angle. Remember, this angle is coming from the center. That's the central angle. So arc measure, same as the central angle. Arc measure, same as the central angle. So this central angle, right? This right here is an arc. Now we talked about this the other day. Now the other thing is, if we draw an angle that goes from here to the other to another part of the circle. Okay. Now, as you can see, this if we go from here to here, that's a big rotation. We don't have to turn as much to see those same parts here. Now, there happens to be a relationship between this angle, this angle, this angle, and this arc. And if we measure this, the last one, this one was 70 degrees, right? Hopefully I did an accurate job here. And I guess I did. Pretty lucky. So 10, 20, 30, 5. Okay? So what's going to happen, this is an inscribed angle. Okay? So central angle is equal measure to the arc that it defines. Okay? Inscribed angle is 1/2 of the measure of the arc. So 35 multiplied by 2 gets 70. Or if we know the arc measure, 70 divided by 2, 35. Okay?